Hi everyone, today we're going to study equivalence class. Let us define equivalence class. Let R be an equivalence relation on a set A. The set of all elements that are related to the element A of set A is called the equivalence class of A and is denoted by this symbol. The equivalence class of A has elements S such that the ordered pair A-S is an element of R. For all S, an element of set A. The general case is to find the equivalence class of A of the relation congruence modulo M. With this, our symbol can be written like this. The subscript is M, and we read this as equivalence class of A of the relation congruence modulo M. Writing now the elements of this, we can write the first element to be that A. On the right of A, the first element will be this A plus M. And the next element will be this value A plus M plus another M. So we have A plus 2M. This pattern will continue going to the right. Now for the elements on the left side of A, the next element here will be the A minus M. Prior to this, the element would be A minus 2M. And prior to this, the element will be A minus 3M. So this pattern will continue for the elements going to the left of A. Now let us see some examples. Example 1. Consider the equivalence relation on the set X with elements from 1 up to 10, defined by X is equivalent to Y if and only if 3 divides X minus Y. Find the equivalence classes. Let us write the first equivalence class. Considering the first element here, the first equivalence class is here. Equivalence class of 1 of the relation congruence modulo 3. Writing the first element, that will be this same number 1 will come here. The next element will be 1 plus 3. That will be 4. Next, 4 plus 3 equals 7. 7 plus 3 is 10. If we add 10 plus 3, the sum is 13, but that is out of the range of the set. So the elements of our equivalence class 1 are 1, 4, 7, and 10. Next is equivalence class of 2 of the relation congruence modulo 3. The elements are starting from 2, 2 plus 3 is 5, 5 plus 3 is 8. Next is equivalence class of 3 of the relation congruence modulo 3. The elements are starting from 3, 3 plus 3 is 6, 6 plus 3 equals 9. We shall continue to write the equivalence classes for 4 up to 10. While doing so, you will find out that this equivalence class 1 is equivalent to equivalence class 4, which is also equivalent to equivalence class 7 and is equivalent to equivalence class 10. Also, that equivalence class 2 is equivalent to equivalence class of 5, which is also equal to the equivalence class of 8. Likewise, the equivalence class of 3 is equal to equivalence class of 6 and also equal to equivalence class of 9. So, the different equivalence classes are equivalence class of 1, equivalence class of 2, and equivalence class of 3. This is the final answer. Example 2. Find the equivalence class of -1 with respect to the relation R on the integers given by R equals the ordered pair AB such that A equals B or A equals -B. Evidently, this relation is an equivalence relation. The equivalence class of -1 is given by, the symbol is here, equivalence class of -1 of the relation congruence modulo R is equal to the elements S such that the ordered pair -1 S is an element of R. For all S, an element of Z, the integers. We know that the elements in Z related to -1 by R are 1 and -1. Therefore, -1 of the relation congruence modulo R equals -1 and 1. This is the final answer. I hope you learned something from this video. See you again next time.